It's really gratifying when a student says, now I feel like science is something I can do, rather than being intimidated by it. I think one of the reasons I gravitated to evolutionary biology is that the fundamental principles are very simple. You can write them down on an index card and carry them around in your pocket. It explains the change in our local stickleback population, all the way to giving us key insights into why we age and die. The fact that a very simple set of ideas can help us explain such a wide range of phenomena is a continuous source of amazement for me. So the honors program's mission is interdisciplinary studies, which means that the students who choose that as the way they want to go in college have really diverse interests and are really curious about the world in general and about how different ideas fit together. That plus the small class sizes I get to teach in honors makes for really engaging, productive classroom conversation. We can cover topics in more detail and do a greater diversity of assignments and explorations. And I get to know the students better and get to listen in on their conversations more in an honors class. And so that gives me lots of ideas for new things to try. And then I can take those new things, once they're more fully realized, into a larger class and see how they work at scale. A lot of students, particularly the non-majors classes, come into my class a little intimidated by science. Often because their exposure to it before was a class where they were supposed to memorize a whole bunch of facts and spit them back on an exam, and that was challenging for them. When I tell students I hope to help them learn to think like scientists, the first thing I mean by that is that they will actively cultivate their curiosity by paying attention to what they see around them as they walk across campus, by reading various media sources, hopefully reliable ones, about the living world, and by trying to learn a little bit more about it. So that's a really key thing, is just being actively curious about the world. Beyond that, once you're curious, you start asking questions, and what I want the students to do then is not just ask questions, but think about ways they might go about finding the answer to those questions. What sort of observational or experimental studies they might do, what data they'd have to collect, how they're going to analyze that data to draw conclusions, what conclusions are fair to draw and what do they need to remain skeptical about. It's a general set of cognitive skills that are applicable everywhere. It's not what we've already learned that gets scientists out of bed and into the lab every day. It's what we don't know. The fundamental feature of science is respect for evidence, and paying attention to evidence, gathering evidence, analyzing evidence is useful in a really wide range of pursuits. Just getting a chance to help people find opportunities that change their lives is extremely gratifying to me.